Hi and welcome to the second of our special edition videos. This is on section 4.2. This is the only video for this section. In section 4.2 we look at the natural exponential function. So what we're specifically looking at is what's known as, and this is why math people and English people don't get along, but it's the number E. Wait, there's no number E. There's a letter E, there's not a number E. Well, this is E because it was named after the guy that discovered it. His name's Euler. I know it doesn't look like how you spell Euler, but again, English and math not getting along with each other. But it's the number E. And by definition, E is defined as the value (1 plus 1 over n to the nth power). So it's defined as the value this guy approaches as n becomes large. So as n goes to infinity, what does this number get close to? And this is what's known as limits, which, if you're here at UNLV and if you have to take Math 181, like I told you guys in the video for section 4.1, that's why I do these videos, because this is a huge part of Math 181. And if you were never introduced to this, as soon as your teacher starts talking about it, you're going to be like, what are they talking about? I've never even heard of the letter or the number E before. So that's what it is. This is what the definition is. It can be shown that E is approximately 2.71828, and it keeps going. It's an irrational number, so it doesn't ever end. It just keeps like pi. Pi never ends. Same thing with the letter E. It never really ends. But as n becomes large, that's what E, the value of E, tends to go to. So the last little bit I want to get to in this video, again, you can see it's super short. It's an introduction to E. What is it? What is its actual value? Is the two graphs. So for A, I want to graph f of x is equal to e to the x. In part B of this example, I want to graph f of x is equal to e to the minus x power. So, the first one, if we think back to the end of video 1, the video for section 4.1, we know that what? If we have f of x is equal to a to the x, this graph looks like what? It looks like this. It's the same essentially for this, right? Because E is a number. Oh, this is when A is greater than 1. Well, A is greater than 1. E, which is our base, is 2.7-ish. So this graph is going to have that same sort of shape. It's going through the point 0, 1. It's heading towards to 0 and it goes to infinity. And it goes to infinity as we near positive infinity. So that's what the graph of e to the x looks like. For B, well, this is what? E to the minus x is the same as what? It's the same as, so if we think of this like this, e over 1 to the negative x power. Using our exponent rules, what do? We switch what's inside, make the exponent positive. So this is the same thing as 1 over e to the positive x. So this number now is what? 1 over 2.7, etc., which is roughly a half, which we know a fraction, an exponential with a fractional base looks like what? Looks like that. Again, going through the point 0, 1. So this is my graph of e to the x. This is the graph of e to the minus x. And again, I just point this out so that if you are having to go take Math 181, you're going to use this function e to the x and e to the minus x a lot. You're going to get sick of it. I'm going to give you a heads up right now. But if you've never seen it before, you start the class at a huge disadvantage to everyone else. So here you go. E to the x, the graph looks like this. My domain is what? All real numbers. The range is what? So domain, all real numbers, the range is 0, but it never hits 0. So that gets a parenthesis up to positive infinity. And same thing here. Domain is all real numbers. The range, again, is 0 up to positive infinity. So they have the same domain and range, they just look different. They're the flip-flop of each other on the graph. So that's it. Come on back. We'll start looking at log functions in video 4.3, which will pick up the curriculum for the rest of the semester for 126.